All right, I wanted to go through some of the questions with you on this assignment. Worksheet number 2, review predicting products and balancing chemical equations. The first 4 or 5 questions are just balancing chemical equations. So when you're balancing chemical equations, remember that the 2 here, oh, she can't see that, the 2 right there will only apply to what's in front of it. In this case, there's a bracket, so it would mean there's 2 hydrogens and 2 oxygens. This would be just 1 barium. Over here, I have 2 hydrogens, only 1 carbon, and this would be 3 oxygens. Over here, 1 barium, 1 carbon, 3 oxygens, 2 hydrogens, 1 oxygen. Okay, so to balance, and if you want, you can do that thing like I've shown in class. So you have a barium. I'd like to do OH together, but over here it's not shown as OH. So I'm just going to separate O and H. And then there's some more H's. Here's a C. And then these are more O's. Okay, so let's count up. So on this side I have 1 barium. This side I have 1 barium. Done, good. Okay, this side, oh, I got some more oxygens. So here I've got 2 oxygens, and then here I've got another 3, so that would be 5 oxygens altogether. Whereas on the right side, I've got 3 here and 1 more there, so it's 4. That's going to be a tough one. Okay, hydrogens, I've got 2 here and 2 more there, so there's 4 hydrogens altogether on the left. On the right, I just have 2, so there's 2. Okay, carbons, here I've got 1, and right here I have 1. Really, so it only looks like the oxygens and hydrogens are messed up. Now, what I can do to balance things is I have to put numbers in front or as coefficients to any of these compounds. So I need to put numbers there. Oxygen, so I have 5 oxygens on this side. If I put a 2 here, that's going to give me an extra oxygen. Let's count up your oxygens now. So I'd have 3 from here, plus another 2, so that would be 5 on this side. Same, right on. Let's check the hydrogens. So here I've got 2 hydrogens plus another 2, so that's 4 on here. Now on this side I've got 2 times this 2, so 2 water, so 2 times H2, that'd be 4, so I'd also have 4 hydrogens there. And my carbons are the same, this reaction now balanced. That's sort of a hard one to do because there's lots of stuff involved. Let's try another one. Okay, so here, and hopefully what you want to do is get to the point where your eyes can just go to something that's cockeyed, that's different. So here I see 1 hydrogen, here I say 2, I have to fix that. So I'm probably going to put a 2 in front of this. So that would give me 2 hydrogens, and I have 2 hydrogens here. Hydrogens are good. Now it gives me 2 sodiums, which I have there. This is good. It also gives me 2 carbons. So I have 1 carbon here and 1 carbon there. So there's 2. So my carbons are good. Maybe I should keep a tally here. And then oxygens, there's 3, but I have a 2 out front. So 2 times 3 would be 6 oxygens on the left-hand side. And then I've got 3, 4, 5, 6. I have 6 on that side. So it looks like I'm balanced. When you finish balancing, you probably want to, whoops, I erased something there. You want to erase all the little, all this little stuff that I'm doing, the little marks, and just keep in the number that you put in there. So I think to balance that, all I had to do was put a 2. Try the next one. Okay, silver nitrate and copper goes to copper 2 nitrate and silver. Oh, did I already put the answer in there? Let's see. Maybe that's giving you a clue. So this gives me 2 silver. I can maybe assume that that's not there. Let's assume that there's nothing there. We might have to put a 2 there, but let's just see. So this tells me, this is a good spot where this is a nitrate and that tells me I have 2 nitrates. And over here, that's a nitrate, but there's only one of them. So to get a 2, I can't put a 2 out back here. To balance the whole reaction, I have to put it out front. So I'd put a 2 there. That would give me 2 nitrates, but it also gives me 2 silvers. So I do need to put that 2 here for the silver. Now let's look at copper. I have 1 copper here, and I have 1 copper there. Remember that 2 at the end only applies to what's in brackets. So there's 1 copper, that reaction's balanced. Oh, again, I should erase all that little stuff that I'm doing. There. Whoops. So that would be balanced. Try another one. Sometimes you have to do quite a few of these to really to get the hang of it. And some, like in this question, you have to not only come up with the products, oh, this one gives you the products, but you have to come up with the formulas too. So they say sodium fluoride. Okay, so sodium's Na, and fluorine is just an F. Let's see if that's balanced. When you look at the periodic table, sodium is a positive, and fluorine is a 1 minus. So electrically they're balanced. So that's the right way to write sodium fluoride. Reacts with bromine, so it's Br, and bromine is one of the diatomics, so it always comes as a twin or double, 2 of them. Okay, it reacts with that to produce sodium bromide. So sodium and bromine. Sodium's a 1 plus, bromine's a 1 minus, so those balance off too. That's the correct way to write that. Plus fluorine by itself. So fluorine's by itself, it's diatomic, so it would always come in 2s. Okay, I think that's the correct way of writing the equation. Now let's balance it. Count how much stuff you have on each side. 1 sodium, good. 1 fluorine, 2 fluorine, not good. Got to fix that. So to get 2 fluorines on this left side, I can't put 1 there because that would make the thing electrically unbalanced. But I can put a 2 out front. So when you balance the whole equation, you put numbers out front of any of the compounds. Okay, so that gives me 2 fluorines, but that also gives me 2 sodiums. So let's put a 2 here, and that'll give me 2 sodiums, but it also gives me 2 bromines, which I have. Therefore, now the reaction is balanced. In class, I didn't put a 1 there, and you don't have to put a 1, but sometimes it's nice to put in a coefficient for each one of the compounds. Let's try another one. Butane burns. So butane is C4H10 plus oxygen. And notice that I'm not putting the states in, like solid, liquid, gas. At this point, maybe let's just try and make sure we're getting the compounds written right and the things balanced. But keep in mind that we do need to do that, the states thing as well. And I guess we could. Butane is probably going to be a gas when it burns. Oxygen is a gas. It produces carbon dioxide, which would be a gas. And if it's burning an engine, the water is probably also water vapor. So I'll make it a gas. Okay, so now I need to balance this reaction. Let's count stuff up. I've got 4 carbons. Here I only have 1. Remember that 2 only applies to the oxygen. So to balance that, I could put a 4 there. Feels good. Then let's look at the hydrogens. There's 10 hydrogens over here. Here there's only 2. So what can I put in front of that to balance it? If you said 5, you were right. Good. Okay, so the carbons and hydrogen got them. Let's check oxygens. There's 2 oxygens there. Over here I've got 8 oxygens. And then here I've got another 5 oxygens. So altogether, the oxygens, I have 13 oxygens. So what number could I put in front of the 2 to make 13? I guess you could write 6.5. That would be correctly balanced. But often we don't like putting half of for a unit there. And so if that ever happens to you, what you can do is just double everything. I'm just going to rewrite it again. C4H10 plus O2 yields CO2 plus water. Okay, so and I said I was going to double everything just to get rid of that decimal. So if I double everything, I'll put a 2 here. That gives me 8 carbons, so I need an 8 there. Okay, this also gives me 20 hydrogens, so over here I need a 10 to give me the 20 hydrogens. Now let's count up oxygens. 8 times 2 would be 16 oxygens, and then 10, I have another 10 oxygens. So altogether on the right side I have 20 oxygens. So the number I need to put in front of there would be half of that, or 13. There we go. Now that reaction is balanced. Okay, hopefully you're getting on to it. Let's try, I don't know if I have. Oh, this is one where we have to predict the products, identify the reaction type, and balance. Oh, okay. Lots of work for this one. So aqueous solution of barium hydroxide. So barium and hydroxide is OH. Okay, now barium is a 2 plus and a hydroxide is just a 1 minus. So to balance that formula, I need to put a 2 there. Okay, there's one thing down. Mixed with aqueous solution of sulfuric acid. So sulfuric acid is H2SO4. Okay, now both these they say are aqueous. I'll just put that in. Yields. This to me, in terms of what type of reaction I have, since I have 2 things here and 2 things there, I'm calling it a double replacement. So the barium is going to hook up with the sulfate, and the hydrogen is going to hook up with the hydroxide. So barium is going to go with sulfate. Let's figure out charges. Barium is a 2 plus, sulfate's a 2 minus. And all those you can get right from your periodic table, right? So they're even Stevens, so I don't need to do anything down below with subscripts. Plus, and then when H goes with OH, I can just write it like that. H and OH. Hydrogen is positive, hydroxide's minus, so again they're even. I don't need to put any subscripts in. Okay, so I think I've predicted the products correctly. I've told you what kind of reaction it is, probably a double replacement reaction. Specifically, you could call it a double replacement neutralization reaction, because this is a base, whoops, the barium hydroxide is a base, and the sulfuric acid, of course, is an acid. But now let's balance it. Let's go to see what stuff looks goofy. So I'm looking here, and I see 2 hydroxides. Over here, I just see 1. So to fix that, I'll put a 2 out front here. When I do that, so I get my 2 hydroxides, but I also get 2 hydrogens. So over here, oh, I've got 2 hydrogens. This is good. Here, oops, I have 1 barium. Here I have 1 barium. Here I have 1 sulfate, and here I have 1 sulfate. So I think just by putting a 2 right there balances that equation. Try another one. Actually, we'll try them all. I like them. Aqueous solution of potassium chloride. Okay, potassium is a positive, chloride is a minus. They're even, so it's just be KCl. Okay, so I've got KCl mixed with, when they say aqueous, we can put that in, plus sodium sulfate. So I have sodium, which is a positive, and I have sulfate, which is a 2 minus. So to balance, I think I need 2 sodiums there. Okay, so now I've got my reactants. Now I have to figure out what type of reaction it is and then balance it. Again, this time I have 2 things here, 2 things there. Again, I'm treating sulfate as a thing by itself, one thing. So I think it's a double replacement reaction. So like I said before, potassium is positive, so it wants to go with a negative. it's already with a negative, but over on the other side, sodium's a positive and sulfate's a 2 minus. So this potassium will try and react with the sulfate. Okay, so I have a potassium, which is positive, and a sulfate, which is 2 minus. Again, I need to balance that chemical reaction. Looks like I need to put a 2 here to balance the charges. Okay, plus, and I could look up to see what the state of that is too. But again, I'm not going to worry about that for right now. Okay, so then I've got sodium is going to hook up with the chlorine. So sodium and chlorine. Sodium's a 1 plus, chlorine's a 1 minus. They're even, so I don't need to put any subscripts down below. Okay, again, so I have a double replacement reaction. I think I've identified all the products. Now let's balance things. So what's out of kilter? 2 potassiums, only 1 potassium. So I could put a 2 here. That'll give me 2 potassiums. But when I do that, it also gives me 2 chlorines. So over here, I need to put a 2 there to give me the 2 chlorines. So I have 2 chlorines, but then that also gives me 2 sodiums. Oh, which I have already. Good. Now sulfate, there's 1 sulfate here, and there's 1 sulfate there. So now the reaction is balanced. Number 8, aqueous solution barium nitrate. I think this is another double replacement reaction. Okay, so barium and nitrate. Nitrate's charge is a minus, barium is a 2 plus. So to balance this, I'm going to need 2 of these. Okay, now that's chemically balanced. So that's the correct formula for barium nitrate. Plus, reactant with potassium phosphate. So potassium and phosphate. Phosphate's a 3 minus, potassium's a 1 plus. So to balance that formula, I need to put a 3 right there. Okay, now I've got my reactants written correctly, I think. So now let's determine what the products will be. Barium's a 2 plus, nitrate's a 1 minus, potassium's a plus, phosphate's a 3 minus. So that this plus here is going to go with this minus over there. So it'll be barium and phosphate together. Barium's a 2 plus, phosphate's a 3 minus. So it looks like I'm going to have to go to 6 with this. So I'll put 3 here. That'll give me 6 positive. And then with this one, I'll put it in brackets, put a 2, and that'll give me a 6 minus. Plus, and then potassium's going with the nitrate. Potassium, nitrate. Potassium's a 1 plus, and nitrate's a 1 minus. Oh, they're even, so I don't need to put any subscripts in. Okay, let me get rid of all my charges here. Those don't belong in the final balanced chemical equation, those charges. We use them just to help us identify products and identify correct formulas. Okay, what's out of kilter? 1 barium, 3 barium. I better put a 3 out front there. But when I put a 3 there, that gives me 3 bariums, which I needed, but it also gives me how many nitrates? Since there's a 2 here, 3 times 2, that'll be 6 nitrates. Over here, I only have 1 nitrate. Again, you're treating nitrate as a whole group. So I need to put a 6 there, because that'll give me my 6 nitrates. So I have 6 nitrates, but now I've got 6 potassiums on this side. Over here, I only have 3, so what do I put in front there? Hopefully you said a 2. You put a 2 there, that'll give you your 6 potassiums. But now it also gives you 2 phosphates, which I have over there. Equation is balanced. Okay. Next one. Number 10. Aqueous solution of lead 2 nitrate. So lead, and it's a 2, so I know it's a 2 plus. And nitrate. And nitrate's a minus. So to balance those, I'm going to need 2 of those guys. Okay. Plus reaction with sodium iodide. Sodium and iodide. Sodium's a 1 plus, iodide's a 1 minus, so they're even. So again, I don't need to put subscripts. I'm thinking double replacement again. Give us something other than double replacement. So this was a 2 plus and this is a minus. This was a plus and this is a minus. So this plus is going to go with the other minus. So I'll have a PB and an I. I is 1 minus and PB is a 2 plus. So to balance that charge or that formula, I need to put a 2 there. That'll give me a 2 minuses and 2 pluses. Okay, good. And then the sodium is going to go with the nitrate. So plus sodium and nitrate. Sodium's a 1 plus, nitrate's a 1 minus. They're even. I don't need to put any subscripts in. Now let's balance. Lead, even Steven. There's 2 iodines, and here there's only 1. So if I put a 2 in front there, that gives me the 2 iodines, but it also gives me 2 sodiums. Over here I only have 1 sodium. So I'll put a 2 out front. That'll give me the 2 sodiums, but it also gives me 2 nitrates, which I have over here, balanced. Again, if you want to put a 1 in front of things that don't have a number, you can. Oh, here, finally we get a different one. So here, this looks like it just is a compound, so 2 elements combined, and they're wanting to know what's happening. I'm thinking what's going to happen is they'll just break apart. So I'm going to get mercury plus oxygen, and when oxygen is by itself, it's always as O2, it's diatomic, right? Okay, so now let's balance. I have 2 oxygens here, only have 1 there. So I'll put a 2, that'll give me the 2 oxygens, but now I've got 2 mercuries on this side, so I need a 2 in front of the mercury there, balanced. Cesium plus fluorine. Looks like, so this is just an add or an element, and here's just an element. So it looks like they're trying to combine those. So on the right side, I'm going to get cesium fluoride. When I look on the chart, cesium is a 1 plus, fluorine is a 1 minus. So they're even Steven. The formula that is written there is correct. Now let's balance. 1 cesium, 1 cesium. 2 fluorines, only 1 fluorine. Let's fix that. We'll put a 2 there. But when I do put a 2 there, that does fix my fluorines, but it messes up the cesiums. Because now I've got 2 cesiums, so over on this side I need to have 2 cesiums. Now my equation is balanced. And again, if you want, you can put a 1 in front of that. So the whole thing would be 2 cesiums plus 1 fluorine yields 2 cesium fluoride. Okay, next one. Ooh. This, at the start, it almost looks like combustion because you're adding oxygen, but you're not producing carbon dioxide and water on the other side. So maybe it's a quasi-combustion if you want, but usually combustion is carbon and hydrogen reacting with oxygen. So I might call this an other reaction. Okay, let's try and balance it. 1 nitrogen, 1 nitrogen, 3 hydrogens, 2 hydrogens, 2 oxygens, 1, 2 oxygens. That's a pain because everything's balanced except for those hydrogens. Well, why don't I try and put and what I'm looking for is the hydrogens. I have 2 here and 3 there. If I go common denominator 6, let's maybe try that. I don't know if it'll work, but let's give it a shot. So if I put a 2 there, that'll give me the 6 hydrogens. If I put a 3 here, that'll give me 6 hydrogens on that side. Now let's check out and see what we've got for the rest of the stuff. So 2 nitrogens, I'd need to put a 2 here to get the 2 nitrogens. And then here I've got 3 oxygens plus another 2, so there's 5 oxygens on this side, and there's only 2 on this side. Oh, well, that would be easy then. So if I need to get 5, I just need to get, if I put a 2.5 there, that'll give me 5 oxygens. Let me see, 2 nitrogens, 6 hydrogens, 6 hydrogens, 5 and 5. Now, what I said before, and probably a good idea not to have decimals. So to fix that, you just double everything. So the NH3, and maybe I'll follow it through, plus O2 yields NO plus water. So if I put, instead of a 2 there, I'm going to double it to a 4. So that gives me 4 nitrogens. I'll put 4 nitrogens over here. That also gives me 12 hydrogens, so I need to put a 6 there to give me 12 hydrogens. And now I've got 4 plus another 6, so I have 10 oxygens on this side. So to get 10 oxygens here, I need to put a 5 there. Balanced. Next one. Nope, this one looks like I'm burning something. This is a classic combustion question. And it looks like I'm burning propane, C3H8. Again, if you're not sure of some of the names of these, you can check your data booklet because they have most all the names and formulas in there. Okay, so anytime I have fuel burning an oxygen, I'm going to get CO2 plus water out of it. Let's try and balance. So I have 3 carbons here, so I need to put a 3 there, because this 2, remember, only applies the oxygen, not the carbon. So I put a 3 there, that'll give me 3 carbons. I've got 8 hydrogens, so over here I'll put a 4 there. That'll give me the 8 hydrogens. Now let's count up the oxygens. So 3 times 2 would be 6 oxygens here. And then on this side I've got another 4 oxygens. So altogether that's 10 oxygens on the right side. So I need to put a 5 right there, and that'll give me 10 oxygens on the left side. Balanced. Next one, benzene burns. Oh, benzene. So C6H6. And if it's burning, I'm going to say O2 yields. It's always going to produce carbon dioxide and water. Now let's try and balance. So there's 6 carbons here. I'll put a 6 there. There's 6 hydrogens. I'll put a 3 there. Okay. Now let's do oxygen. 6 times 2 is 12 oxygens. And then here this would be another 3 oxygens. So it's 15 oxygens altogether. Oh darn, it's an odd number again. So I guess I could put 7.5 oxygens there. Or, like we've done before, we can double things. Let's do that. C6H6 plus O2 yields CO2 plus water. So I'm just going to double this. That'll give me 12 carbons. So I need to put a 12 there for 12 carbons. This also gives me 12 hydrogens. So I need to put a 6 there. And that'll give me my 12 hydrogens. Counting up oxygens on this side, 12 times 2 would give me 24. Plus, this is just 6. So altogether that would be 30 oxygens on the right-hand side. So I need to find a number for here that when I double it, it gives me 30. Or in other words, cut 30 in half. So this would be 15. So that would be my, that would be my balanced chemical equation. So I'm just going to delete some of this stuff, because you don't need to write that when you're writing your balanced chemical equation. That O doesn't look that good there. Okay, I only have a couple left. 16, magnesium sulfide decomposes. Okay, so magnesium sulfide. So it decomposes. So it's going to break into magnesium and sulfur. But let's make sure this formula is right. Magnesium's a 2 plus, sulfur's a 2 minus. Oh, they're even. So the formula is written correctly. And it breaks into its elements. So magnesium would be one thing, plus sulfur. But here they say write sulfur as an S8. Okay, I got an 8 there. Okay, all looks good. Now let's balance. Magnesiums are good, sulfur's not good. So let's put an 8 in front of here. That'll give me my 8 sulfurs. But I also now have 8 magnesiums, so I need to put an 8 there to give me my 8 magnesiums. Balanced. Okay, 3 or 4 left. Bromine. So bromine by itself, it's always Br2 plus tin 4 iodide, so SNI. Now tin, this tells me it's a 4 plus, and iodine's a minus. So to balance that, I need 4 iodines. Okay, I think I've got my formulas written correctly. Now let's do the single replacement thing. Bromine is a minus, iodine's a minus, tin is a 4 plus. So currently tin is hooked up with the iodine. So if we're going to have a reaction, tin will want to hook up with the bromine. So it'll be a tin and a bromine. Bromine's a 1 minus, tin's a 4 plus. So I need a 4 right there to balance off those charges. Plus, and then iodine goes by itself. And I know when iodine's by itself, it's always written as I2. Okay? Make sure you don't keep that 4 there. Because iodine, when it's by itself, isn't a 4, it's always a 2. Okay, now balancing things. I have 2 bromines here. I've got 4, so if I put a 2 there, the bromines are good. I have 4 iodines here. I only have 2 there, so if I put a 2 there, iodines are good. Tin is 1 there and 1 there, so all is balanced. Good. So there's that balanced chemical equation. There's a 2 there. Okay. 18. Sulfuric acid, H2SO4, plus potassium hydroxide, KOH. Okay, KOH, let me just confirm that. It's a positive, hydroxide's a minus. Yeah, they're even, so that's good. Looks like a double replacement reaction again, because there's 1, 2 things here, 1, 2 things there. Keep in mind those polyatomics, you try and keep those together as a unit. And often that works. So this positive hydrogen is going to hook up with that hydroxide. So hydrogen hydroxide. I guess you could just call that water. I like to leave it though as HOH because it helps me balance. And then potassium will go with the sulfate. So K and SO4 go together. Potassium's 1 plus, sulfate's a 2 minus. So I need 2 potassiums to balance that. Okay, I've got my products. And now I need to balance things. Erase this stuff. Okay, what's off kilter? Looks like there's 2 hydrogens here. Whoops. So I need 2 hydrogens there. So I'm going to put a 2 there. Notice I didn't even look at that hydrogen there because it's a group. It's a hydroxide. So I don't think of it as an oxygen and a hydrogen. I think of it as a hydroxide. Okay, but by putting a 2 there, whoops, by putting a 2 here, that gives me 2 hydroxides. So over here, I need to put a 2 in front of that to give me those 2 hydroxides. But that also, the fallout from that is I get 2 potassiums. Over here, well, I have put 2 potassiums. I have 1 sulfate, the reaction's balanced. Good. Okay, 2 more. Number 19, solutions of mercury 1 phosphate. Okay, mercury, and it says 1, so it's a 1 plus. And phosphate is a 3 minus. So to balance that, I put a 3 there. Now the charges are good. I've got 3 plus on the left and a 3 minus on the right of that compound. Plus tin 4 chloride. So tin, and this 4 means it's a 4 plus version of the tin, and chloride is always a minus. To balance those charges, I need to put a 4 right there, and now it's balanced. Okay, So this was what was that, a 1 plus? I should have erased those. This is a 3 minus. This is a 4 plus. This is a 1 minus. Okay, so who's going to go with who? I'm calling the tin going with the phosphate. So the tin and the phosphate get together. So tin's a 4 plus, phosphate's a 3 minus. Ooh, this looks like I have to go to 12. So I'll put a 3 there. 3 times the 4, that'll give me a 12 plus on this side. So how many of those phosphates do I need? Since there are 3 minus, each of them are, if I put a 4 there, that'll give me a 4 minus. Now that compound is balanced. Plus, so I did the tin and the phosphate, now I've got the mercury and the chlorine. So it's mercury and chlorine. Mercury is a 1 plus, chlorine is a 1 minus, even Steven. I don't need to do anything with that. Now you notice that I'm just saying, hey, it's a 1 plus 1 minus. You do have to check that out on the periodic table, or on the complex ions, wherever, just to make sure you've got the ion charges right. Okay, I think that I have everything correct there. Now let's go and balance. So I've balanced the compounds themselves, but now I need to balance the whole chemical reaction. What's off kilter? That phosphate seems a little funny. There's 4 phosphates there and there's only 1 there. So I should put a 4 in front of that. But then that gives me 12 mercuries. Okay, I can put a 12 there. That gives me 12 mercuries, but that also gives me 12 chlorines. So over here, what do I need to put there to give me 12 chlorines? If you said 3, that's right. So 3, that gives me my 12 chlorines, but now I've got 3 tins, which I have over there, balanced. Last question. Salt decomposes. Okay, salt is, there's lots of different types of salt, but I'm sure they're referring to NaCl there. So salt decomposes, so it breaks into its elements. So it'll be sodium plus chlorine. Chlorine written by itself is always a 2. And now I need to balance. So there's 2 chlorines here, so I need to put 2 there. But that gives me my 2 chlorines, but it also gives me 2 sodiums. So I need to put a 2 there, and that'll give me my sodiums. So everything's balanced now. Okay, I hope that helped you out in writing products for a reaction and also balancing them. Seems to be there's always 2 things you have to worry about. So getting those products and making sure that you balance each compound by itself. You didn't have to in this question, but the one before you did. So make sure you're getting the products written correctly and then balancing the whole thing.